Hello friends, so welcome in the second part of the timer interrupt. So initially first part I have demonstrated with the simulation, right, Proteus, and this time we will understand the same with the hardware. And this time, since we have the hardware, we will have the actual delay. Let us say if I will use 5 seconds of delay, then we will have a actual 5 second interval, right? So in last video, what we did, we have one button or one switch. When that switch pressed for certain amount of period, then your controller will display something, like it will turn on the LED, or it will send some message on UART3 or whatever UART we have used, right? So basically the idea is that your sensor is sensing some quantity, but you want that your sensor, if sensor continuously sends that quantity for certain amount of period, then you will have some action, right? Now if you will do this with simple HAL delay, then it will be blocking, concept. Blocking means what? It will block the overall thing, right? It will block your uh, processors, execution flow. It will continuously block until and unless you will reach to the final result. But with the timer interrupt, what we can do, we can achieve this with ongoing process. Mean our ongoing process continuously executed, and along with this timer will also continuously count the thing. And whenever you reach up to that particular period, let us say that particular quantity is continuously available for 5 seconds or 10 seconds, your controller will generate required action. Along with this, your ongoing process will not affected, right? That is overall uh, idea. So this is the pin out for the Nucleo 144 board. We have selected Nucleo 144 board. Even in this circuit also, you can see this is Nucleo 144 board. This is simple proximity sensor connected with the PB4. So output of this sensor will goes into the PB4 pin. These are power supply and ground. Along with this, we are also using onboard LED, which is PB7. So if the object is continuously here for 5 seconds or 10 seconds, it will turn on the PB7 LED. Okay, along with this, to demonstrate the ongoing task, we are using UART. So on UART, we will display continuous message, and from that message, you can understand that some continuous operation is ongoing, and along with this task also of this board will perform, right? So let us say after clearing out all the pin, first of all, let us connect these crystals RCC. Okay, now let us choose timer. So this thing we already covered in our previous video, so I will not explain that in that much detail. Now I'm using timer for internal clock. Okay, and prescaler we will take same as our last video, 799. Now here, since we are working with a board, we have to understand the clock. Okay, what is the clock? So for that, go to the clock configuration, and here you can see this is the overall thing. So here we have 96 megahertz clock with the prescaler divided by 2 multiplied by 2, and this 96 megahertz clock is available for APB1 timer clock. So our timer clock is actually 96 megahertz. So in our previous video we use 8 megahertz, but now this is 96 megahertz. Okay, now with 96 megahertz, if I will take this prescaler 7999, what will be my ARR? So ARR will actually, what this ARR will tell us, how many ticks to count before resetting, before overflow, right? So if my input clock is 96 megahertz and if my prescaler is 799, so timer clock will be 12. Let us calculate here, divide by 8000, so it will be 12,000. Okay, so per second it will count 12,000 times, and if I want overflow within 1 second, so I have to set this prescaler to exactly 12,000 minus 1 is equal to 11,999. If you have any confusion in this calculation, please watch my previous video. This is simple straightforward calculation. So our prescaler is now 7999 and ARR is 11,999. Okay, so let us select this 11,999, right? So now this timer part is completed. Now along with this, let us also enable the interrupt, because ultimately our whole process is with based on the interrupt only. So let's enable the interrupt. Now let us select our switch which is with PB4. So PB4 should be the input and PB7 is onboard LED, so PB7 should be the output. Okay, so PB7 should be the output. Now PB4 is input. Okay, and so let us set this PB4 in by default pull up mode. Okay, because I will explain you after that why I choose this pull up mode, and let us generate the code. So now whenever this proximity will detect something, it will write into this controller STM32. STM32 will observe this. It will start the counter using interrupt. After certain amount of count, it will generate the interrupt. Interrupt subroutine will call, and interrupt subroutine will take the required action. Okay, and this will be parallel with our ongoing task. So this is overall picture. Now this is our code, and I will use my previous code, right? Previous code I have uploaded, so I will use this code as it is. So in this video you have second learning how to reuse the code. Okay, because we are reusing our code. So this is also you can understand. So first of all, let us use these variables. So this is basically using. Now I will not use this function. This ongoing task is okay. I will use this. Okay. Now second is go to the while one. In while one we have this if loop. Okay. So use it as it is. Here I will use reset. Okay. Because whenever something is or before this proximity sensor, it will write actually low reset. Okay, so we have to check if anything is in front of the sensor, this part will uh, become true, and it should start our timer. Now this time I am using timer 5. You can see from this we are using timer 5. Okay, okay, one more thing I would like to also enable, which is UART3, that was missing. So let us use UART3, because for ongoing task we have to use this UART3 synchronize, and 9600 should be the baud rate. Along with this, by default pin numbers are different, and if I want to use it for my onboard UART, okay, so I have to change the pin. So this thing we have done many times. So if you have any confusion, please watch our previous videos. You will easily understand what I am trying to say. Okay, so here PD8 and PD9 are there, so they are actually multiplex UART pin. So you have to select this PD8 and PD9, so that will represent your onboard UART. Okay, and for further you can check the manual of Nucleo 144 board. Okay, again generate the code. Our previous part will lost because we are now regenerating the code. I think this variable should not change if I'm not wrong, but let us check. If variable will change, I will simply replace this. place this while one code. This should be reset. This should be PB4, right? Because our sensor is the PB4. Okay, and our timer is timer 5, right? So I have to check this timer 5, and our UART is UART3. So for now I will simply remove this. Here I will simply write UART3 and our message ongoing task. Okay, so this is what the logic for while one. So it will continuously display the message ongoing task. Whenever something is in front of the sensor, this condition will satisfied, and it will simply start this timer. Okay, now let us copy the subroutine part. So when interrupt generates, it will come over here. Now let us change this timer 3 to timer 5, PA0 to PB4, because PB4 is a sensor. Here it should be set, okay, not reset. And here PB7, because LED is with PB7. So if interrupt generates, but if we will, means the sensor is not having any input, so it will simply write 0 on PB7 and it will stop the timer. Okay, if this condition is continuously satisfied, means something is continuously there in front of the sensor, your second count should increase. So let us say, let us put a delay of 10 second. Okay, and if 10-second delay is completed, then it will stop the timer. It will write high on PB7 pin, right? Means it will turn on the LED. Along with this, it will reset this flag also, because ultimately we have to continuously do this operation again and again. Okay, so and also let us second count is also 0. Okay, now let us debug the code. So this time if I will put my hand in front of the sensor, after 10 seconds this LED should turn on. Okay, and in if I will do this activity any time, any number of time, but I will not hold this for 10 seconds, nothing will happen, right? And along with this, our ongoing task, which is message display on UART3, should continuously executed, right? Now here I have to change this from 3 to 5, because timer 3 is not valid for this. Okay, so this is how you can reuse the code. You can see with minimum efforts I am reusing the code, and now our project is ready, right? So you can go through my previous videos, you can go through my GitHub repository, you can download the code and you can reuse it. Now release the target. I will generate the hex file, I will upload the hex file, and that's it. It should work, right? Meanwhile, I'm opening real term. That was from my previous experiment. So real term. Now generate the hex file, because we need hex file, right? Again release the target. This time here you should have hex file. Right now it is not there. Yes, this is the hex file. And now I will upload this from this configuration, running configuration. My project name is Nucleo 144 timer test. So select that project, Nucleo 144 timer test. Yes, this is the project. Here also you have to search for release path, release target, apply and run. Now it will upload the code. So you can observe this from this LED also. It will change the color. and you can see now code is uploading. And now let us open this terminal and connect the port, and you can see ongoing task is continuously displaying. Now I am just putting my hand here for, let us say, 3-4 seconds and remove it. You can see nothing is happened, right? You have to observe this PB7. Now let us put this hand for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you can see LED is on. Now I'm removing my hand, and now you can see it is now off. Again, if I will put this for 2-3 seconds, nothing will happen. So here remember one thing, timer is doing its duty by without affecting the ongoing process, right? Here you can see ongoing task is continuously executed, right? So this is what with the hardware. Now I will use this and make a complete understandable project in next videos, so you will have proper understanding that where to use this type of code in real world example. Along with this, I am also working on some real world problems, and I'm about to complete it. So in next video you can also see all these type of latest and you know uh, real-time projects. So for that, please keep watching my channel. Till then, if you like my videos, please share it with your friend. If you like my channel, please subscribe it. Till then, bye bye. Thanks a lot.